Okay. So what we gonna do? Assign the oxidation numbers for each element. In the following. Pen and paper, whichever one works for you. So what's the name of the first one?
Carbon dioxide.
Carbon dioxide.
Carbon is flat.
You sure?
Yeah. Yeah.
What about oxygen? What's oxygen?
It's -2.
-4? +2?
-2.
But it's
-2?
Yeah. 2 in total is -4.
-2.
My fault,
-2, and my carbon is?
+4.
That's what I got too. Okay? What about this? What's the name of this?
Nitrogen dioxide.
Nitroxyl. I apologize.
Is there room for C?
No, there's no room for C.
Nitrous.
No.
There's no H.
No.
Right.
There you go. Nitrite. Nitrite. Okay? So what do we have?
So oxygen we have -2.
Oxygen is? -2.
So nitrogen is +4.
What?
+4. 3.
Can be 3. You have to be.
It can't be 3?
No, it's negative. What is the sign?
There is a sign right here. See that sign right there?
Yeah, I didn't see that.
That sign right there is a negative.
It's
So that's
+3. +3 is negative. Hey, Professor, the sign is way too small. I can see. You gotta.
It's the people that make the font, not me.
So wait.
Wait, hold up.
Hold up.
What you do with that? What you do? You make it.
I promise you, I'm probably going to start saying that now. Hold up.
The N. There's no room for the N, but for the wait, hold on. Let me
There's
do it
rules for the oxygen,
first. Okay. It's
and there's rules for the entire compound. Rule 7.
Oh, cause the.
I just asked if it's a polyatomic ion.
You saying they're talking in your throat like how? How am I supposed to understand that? Hold up. What's up?
So it's just negative. So the N. Wait, I'm lost. Do that one out.
Why are you lost?
I know the 2 is times -2, right?
I don't know, you tell me.
Yeah.
Okay.
Equals -1.
No, look.
Oh, wait, can I try it?
Alright, go ahead, Vic. Are you sick? I'm not looking to catch no cooties from that one over there. I said I recovered yet.
Bush tea.
If you see a bush tea, I drink.
The iron of garlic equal.
Oh Lord, what did she do?
The 2 at the bottom, Charlotte. The 2 at the
What did she do?
The minus up top, then the 2 down the yeah.
You got it.
CH2O. That's that's a hydrocarbon, right?
That's not a hydrocarbon. Okay, you got it right now. There you go. All right. But wait, you're forgetting something. There you go.
Oh, so it's not equal 0, it's equal. Okay, now I see what I'm doing now.
Remember, rule 7.
Okay.
No, I don't. Oh, like one of those.
Yeah, something.
Good job. Extra points. Okay, so what about nitrogen gas?
-3. Because look, I'm gonna tell you why. Look, we're about to talk about these confusing old rules now. Because I was debating with myself while she was doing that. It says the sum of the wait, no. No. Boy, it was right here. It disappeared. I swear it disappeared. Oh, elements in the elemental form have an oxidation number of 0, right? Boom.
Pause, Brett. Where's this here?
No, I confused them. No, plus is the ion. I thought that was the ion. Because you know it's a -3. Wait, no. Forget what I'm saying.
So, but nitrogen by itself is in its elemental form, not nitrogen gas, no?
No, this is elemental form.
Oh, okay. So then it's equal. So then he's right that it's equal to 0. Oh.
Well, I don't know if he was right. Like he went some kind of roundabout way, something. Do we want to be so?
Wait.
K plus and minus 1 though, right? Don't tell me that. It's an ion. It's in an ion form. No. The oxidation of a monatomic ion is the same as its charge.
And what is the charge? Well, what did you just tell me the charge
I
was?
said +1.
You are lying!
I know I said -1, but I'm saying +1 now.
K plus, it is not 1. It's +1. You must give me the sign. Right?
What is the name of that, Professor?
What? This here?
Yeah, carbonic water.
That is formaldehyde.
That they put in dead people?
Yes.
Okay.
Ugh.
And how does that work? What does it do?
The rigor mortis.
What?
What does it do?
What does it do? It helps to preserve your body so when you're in your casket, you look like a person. You don't decompose right away. It freezes. Not necessarily freezes. Think about it, right? Maybe 2 days after somebody dies, you know, they start to kick up a stench because your body starts to rot. Okay? Formaldehyde is kind of like a preservative that it delays rotting for years.
What is the chemical we use for, like in biolabs to preserve animals or
Formaldehyde.
it's the same thing? So how long can it preserve it?
Well, it depends. It depends on the technique that you use to preserve the body. But you have people who buried 50, 60 years, you take them up, you can still get body tissue from them. They're not just a skeleton. Okay?
No.
That's nasty.
No.
How's that nasty? It's part of life.
Okay. Okay.
I want to be gone.
I give you a pair of goggles right now. If
Like
you're right.
30 years later?
Don't find me.
Professor,
Huh?
I get her a pair of goggles right now. CH2O, right? Boom. She said C plus H plus 2O. Isn't it C plus H2 plus O?
I'm gonna need you to.
You know,
I'm gonna need you to give him whatever you want.
What?
oh no.
What?
Where is my subscript?
A
On the
war.
egg.
On the it. So how much hydrogen do you have?
Whatever I don't miss.
Well, now I think 2.
Okay. So how much oxygen do you have?
What I thought you said?
I said what? What does that mean? I don't know. That's a something.
You were really one.
All right. So what do we have for formaldehyde?
C0,
C is 0.
H plus 1,
H is plus 1.
O minus 2.
O is minus 2. Is that what we get in?
What?
So
How?
Do we want to do it?
Is it, you just solved for carbon, right? That's how you got carbon at 0?
Do we want to do it? On the board?
yes, I got what you got, but I'm like solve it real quick. Cause it's like you said you want all the work.
Yes. What rule are we going to be using?
The second one or the first one?
I don't know. What's the second
One
one?
we using one and then
We using one?
No.
or
We And number 6, what does rule 6 say?
Oh, this is what
The
this
self of
Sum of
Equals
the
zero.
Complete combination.
equal to 0. What do we do next?
separate
Separate them. What do we have?
One carbon.
carbon, two
Two
hydrogen.
hydrogen. One oxygen. Three plus two plus minus two.
So equals to equal zero.
What does that mean? This equal to zero is not working.
No.
So it's just what does that mean?
That's the oxidation number. With these oxidation numbers, we're going to be looking at it as, like, you know, our scale. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Right?
So it's neutral. So here the carbon is neutral.
Yes. Well, not neutral. It's just the oxidate where the electrons are is 0. So it's everything pretty much even. Yes.
I have a question.
Yes.
So, when you said in the beginning that it's oxidized,
Was it
does
compound? Very good.
oxidize if the oxygen number goes up,
No, 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 no.
if it increases?
It's oxidation,
Yeah.
not if it's oxidized. You have something else going on there that we're gonna get to. We're gonna get to in a little bit. But if you increase your oxidation number
From reactant to product?
from
So
reactant
then you have
to
to
product,
find it of the product too?
there you go. We're gonna get there in a second. Okay? Alright, so in redox reactions, we have ions will oxidize an element. Therefore, the ions are reduced. If we look at this equation right here, okay, we have copper metal reacting with 2 silver ions to produce copper ion and 2 silver metals, right? So what has silver done? Silver has done what?
Keep the proton.
No, no, no. Remember, protons ain't moving now. What happened? What
It
the?
changed the state.
No. Well, yes, it did change the state, but in terms of silver, what did silver do to copper?
Give it charge.
It give it.
No, takes the
It took away how many?
1,
2.
It took away 2 electrons. Okay? So if you have, silver has gained electrons, copper has lost electrons. Alright? So again, your ions, your silver ion was reduced because you gained, to be reduced, you're gaining electrons. And the copper was oxidized because it's losing electrons. Do you see that? No? Alright, so let's take that again then. Remember the chart that we had for oxidation and reduction? The last example for oxidation is if you lose electrons, you are undergoing oxidation. If you gain electrons, you're undergoing reduction. Okay? So here, where is silver on this chart?
What do you mean?
On the charge chart,
+1.
right here,
Okay.
right? What does silver have to do in order to be neutral?
Get rid of one.
Get
Gain one.
It's going to gain 1 what?
electron.
Gain 1 electron.
So it's being reduced.
That's exactly what it did. It took the electron from copper, and now it's neutral. Okay? Where is copper on the charge chart? Neutral at 0. Where does it end up? At +2. It needs to give up.
Oh, okay, so that, okay, so that's what's at the, okay.
So here the copper
Because
is
here it had a plus and then there it doesn't, for the silver,
Yes.
right? And there it doesn't, and for here, there was none and now it has two.
Yeah.
Okay, okay, now I see.
so here the copper to the oxidation and silver to the reduction.
We ain't get there yet. We ain't get there yet. We're gonna take that easy.
Hey,
Okay?
Professor.
Alright.
The equation states 1 mole of copper reacts with 2 moles of silver.
Sulfide. Oh.
There you go. Silver ion. There's a charge right there.
That's a +2.
That's a plus charge.
A plus charge, right? And on the product side, copper has a 2+ charge, and silver. So silver gave copper.
Silver stupid.
I'm not seeing that.
Alright, bet. You have your bills cost $200. Okay? Me right here, I'm short $50 of my bills. So what I do, I sneak over and I borrow $50 from you. So now I'm straight on the product side. Now you are short when you were straight. Do you get that?
So when you have no charge, you're straight?
Yes, you're straight. Good.
So that 2+ charge means that you lost 2 electrons.
Very good.
Okay, there we go. That's good.
Okay. So your silver ion is has oxidized your copper metal. Okay? Now if we had the reverse reaction, is this possible?
Just see the charge.
There you go. This reaction does not occur because we have an additional activity series. So this is a second activity series, not to be confused with the first. Alright? This activity series has to do with metals in aqueous solution.
You have this in the
Do we
side,
have it
right?
on the side?
Yes, page 15.
There you go. Okay?
Oh.
So remember in your first activity series, how was it? How did we organize what can be removed?
Like higher?
The higher one will displace the bottom one. It is flipped in this case. The lower you are, you can displace the top.
We have to memorize this?
No,
Okay, good.
you just have to know how to read it.
So the lower one displaces.
Displaces the top. Can oxidize the top. But the other way does not happen.
What is the like 2 electrons and stuff inside?
Oh, these are your simple iron equations. Don't forget those.
What's wrong with the hydrogen?
Nothing wrong with the hydrogen. That's like baseline. We got it? Okay, now we into my reducing agents and and my oxidizing agents. Now, you guys may have heard of Leo says grr
Yeah.
or oil rig.
Yeah.
I don't know nor follow either one of them. I have made up my own little acronym that will never, ever steer you wrong. Okay? Your reducing agent.
Sorry.
Your reducing agent is the substance that contains the element that is oxidized during the chemical reaction. Do we get that? My little hint is POR. Positive, oxidized, reducing agent. This means once you find your oxidation numbers for your reactants and your products, you look at each individual element. If the element has become more positive, it was therefore oxidized and it is part of your reducing agent. Then you have the oxidizing agent. Your oxidizing agent is a substance that contains the element that is reduced during the chemical reaction. I say NRO. Negative, reduced, oxidizing agent. If you look at the elements themselves, from reactants to products, if the element has become more negative, it was reduced and it is therefore the oxidizing agent. Do we get that?
The substance that contains an element that is oxidized.
Oxidizing agent is oxidization.
What?
Like the example of oxidation and the reduction. So oxidizing agent is the oxidation. Like
Is the oxidation. It's what's oxidized.
So the POR is what's
Oxidized.
And the other one is what's reduced.
So let's take an example.
Wait, go back 1 second.
Okay, now I'm confused.
Don't be confused. We're going to see it. Don't be confused. We're going to see it. Alright? Alright. First equation. We have 1 mole of sulfur reacting with 1 mole of oxygen gas to produce 1 mole of sulfur dioxide. Right? Now, let us assign our oxidation numbers for everybody on my reactant side.
Before that, can we figure out what is oxidizing?
No,
You need to find the numbers first.
you gotta find the numbers first. Then you can figure out what's oxidizing.
Didn't we do that before without the numbers?
So isn't sulfur 0?
Sulfur is 0. Why? By rule.
Because it's by itself.
There you go. Rule 1.
O2 is -2. Oh, it's by itself, so it's 0 as well.
There you go. So both sulfur and oxygen gas
it's zero.
are 0. What about sulfur dioxide? What is oxygen in sulfur dioxide?
-4.
Negative who?
-2.
Negative 2. Therefore, what is sulfur?
+4.
+4. Alright? So now here's where we're going to apply our POR, and NRO. Okay?
Okay.
So from sulfur on the reactant side to the product side, what has it become?
More positive.
More positive, so therefore it is oxidized and therefore the reducing agent.
So it's POR.
It's POR. So your oxygen has gone from 0 to, it has gotten more negative. So therefore that falls under NRO. So it is therefore reduced and it is the oxidizing agent. Yes.
Why is sulfur +4?
Solve it.
oxidation level. And then oxygen, maybe 2 oxygen times -2 equal to -2.
Equal to 0.
It's -4. 2 times -2. What is this equal to? A positive. What is?
0.
Thank you. So we have sulfur.
Oh, I see. -4. Plus minus. And then sulfur will be +4.
Check she know. Check she know. Don't tell me first. And she and no. Did we get it? No?
You call it the reductant or reducing?
Oxygen gas is the oxidizing agent. Sulfur is the reducing agent.
Reducing agent.
Like I said, POR and RO will never mess you up. I don't understand Leo says girl and oil rig. I don't understand it. So therefore, my POR and my NRO, they work.
That's Monica.
Yes, it is.
What does it stand for? Do you know?
What?
Oil rig and Leo sister.
Oil rig.
Oxidation is like.
Who knows what oil rig is? Nobody? Okay, so what about Leo says girl? You know what Leo says girl is?
You
Lose.
actually heard about it. You didn't
Oh.
actually know.
Oh.
Lose electron.
That's true.
Lose electrons oxidation.
Yeah, I'm gonna need you to stop.
Gain.
It's Leo says.
Leo says girl.
Yeah.
I think I heard that last semester.
I heard that in Bio 201. I don't know if that's any teachers.
I know we're about Leo, so we can move on.
Okay. Here we have more examples. Determine the oxidation numbers for each atom represented in the following equation and identify the oxidizing and reducing agents. When you're trying to figure out the oxidation numbers, you can ignore the coefficients. Don't choke now, eh? I'm a CPR license expire. Don't choke.
Mine too.
Right? Don't choke, please.
Don't you need that to teach?
No, like I ain't gonna save your life, like child.
You know, it's like me. Get in front of you and you wanna see me and
You wanna
jump in
see
me and turn
me
it
now?
up. And jump in me and turn it up. You're gonna follow you.
Lord, all I have to do is show somebody what's on here. That's it. So what do we have?
0 and 0.
For who and who?
Aluminum and oxygen. Them by themselves.
Is that oxygen?
Oxygen gas.
Thank you. There's a difference.
-2.
Uh-huh. Alright, so
Also, you
aluminum.
have to take the state into consideration.
No, we have O2. O2 is never oxygen. It's oxygen gas. Aluminum.
Aluminum is +3 and oxygen -2.
For who? For which one are you talking about?
Go for the last one, O2 gas
Product
is 0.
side. Right, this is also 0.
Yeah, that's what I said.
So therefore, aluminum is +3, oxygen is -2.
When I learned about the alum,
It's the English version versus the American version.
why American changed their name? of it?
Don't ask me, American is whatever it wants. I am not American. Alright? So now we can fix wait. Hold up. Look at your face.
Yeah, hold up.
+3.
It's 3 times
Aluminum is +2.
-2, no? You get -6.
Right? How many aluminums do you have?
Oh,
So therefore what do you need to do?
wait.
Don't
Wait, you have to divide it? If there's, I thought you said you ignore the thing.
I said the coefficients. You don't ignore the subscripts.
Oh, there's 2 of those.
Uh-huh.
But I thought it was equal to 0, no?
It does equal to 0. Let's solve it.
Yeah, please. I'm getting 6. Positive 6.
So you tell me what to do.
You do, I know the AL, right? No. Do that side first?
No. You're doing aluminum oxide, but there's something that goes in front of aluminum. How many aluminums do you have? 2 aluminum plus
3 oxygen.
equals.
0? Okay.
We don't have any room for aluminum.
So then, how come it became 3?
Oh, my fault.
Oh, okay. 2Al plus 3 times -2, which goes to 0. And you get 6.
What 6?
-6 minus 6 equals 0.
So you have 2
Oh, we gotta get rid of
ALs.
that 2.
How you get rid of this 2?
Divided by 2. Oh, okay.
Right? So now you're going to look at what happened to your aluminum. Going from reactants to products, aluminum became what?
More positive.
More positive. So therefore it fits under whom?
Reducing.
It is a reducing agent, POR. Oxygen gas has become more negative, so therefore it is the oxidizing agent because it fits under NRO. That's what I got. Did we get it? Try another one. But remember, you guys have to be able to speed up because we only have a certain amount of time. Especially on the final, you have less time per question than we have on my exams. Where you see butane? What is the, see, you're going back to the chapter 1. If you have,
Ethane, propane, methane.
thank you.
It has to be one
They
of
don't
those.
look like that?
What, this?
Yeah.
Just a check.
Yeah, but how many carbons do you have?
Oh, it's going to call.
Wait, you want us to do it for the last?
All of them.
You mean all of them as well?
All of them.
That's only one equation though.
Yes, so you have to find the oxidation
When
numbers
you
for
mean
all
all
of
of them,
them.
that's what you mean all of them. Alright.
What is that one you wanted?
Oh, it says Bernie Sanders.
Ah.
You the bird. That's carbon monoxide.
Yes, sir.
Poisonous, right?
Very.
Minus 2. The goal is to get 0, right, on the product side?
No.
No, on the reactant side?
No. The goal is to solve for each atom. Whatever it is, doesn't matter what it is. If it's neutral, you must set it equal to 0. And then solve for what you don't know in the rules.
So for like the reactant side now, that has to be set equal to 0.
No.
Because
Each individual compound must be taken as its own entity.
oh, okay. hydrogen just be flopping around, right?
What you mean be flopping?
Hydrogen just don't care. Hydrogen just have one kid on the
Well,
planet.
no, because hydrogen will change.
Yeah, so it just don't care.
No, it does care.
No.
Did you find the oxidation numbers for each atom in every single one? No.
As I'm doing it.
No, I'm gonna need you to. Okay, go ahead.
Let's see it four.
Yes.
Is carbon another one that's just changing?
I don't know. You tell me.
If in reactant side and the product side, the oxidation number is same. So what does that mean?
You can ignore it.
You can ignore the
I think I found it, Professor.
What you find?
So carbon on the product, on the reactant side is +2, and oxygen is -2, and then hydrogen gas is 0, and that reacts with H2, which is
It reacts with?
no, it produces H2, which has an oxidation number H, which has an oxidation number of +1, and O has an oxidation number of -2, and plus the methane, which has carbon, and the methane has an oxidation number of -4.
Okay.
And the hydrogen has an oxidation number of +1.
Right.
How the hell we got there?
Where? Which one?
What's that gas?
What's a gas?
Oh, that's okay.
Wait, can you, wait, hold on. You got C equals. How's it +2?
What's
For
plus
C,
two?
for the carbon?
This one?
Yeah.
What's the rule for oxygen?
It's -2.
So therefore, how do you get this to equal to 0? What does carbon have to be?
Oh, 2, okay.
What does it have to be?
+2.
There you go. So now, who stays the same?
oxygen.
So we can ignore him for now. Okay? So now, you look at carbon. What has happened to carbon?
It's lose over.
+2 to -4.
There you go. So what has it become? More? It's become more negative. So therefore, what can we say about the compound that holds carbon?
Oxidizing agent.
It is the what is the oxidizing agent? Carbon, what? Carbon monoxide. So whatever atom is doing is the oxidizing agent, you must tell me that compound that it belongs to. Okay, so don't just tell me that carbon is your oxidizing agent. You must tell me carbon monoxide is your oxidizing agent. Now, hydrogen. Hydrogen has gone from what to what? 0 to +1. So it has become more. So therefore it is the
Pure.
reducing agent. So hydrogen
Gas.
gas is your reducing agent.
I don't know how we did. I don't know what that is. H2O gas.
What? H2O gas.
How did he get this?
What is H2O gas?
What's it big for?
Thank you. So what is the rule for oxygen?
That's one.
What is the rule for oxygen?
It's oxygen gas is negative.
No. Oxygen atom in a compound. What is the rule? That's rule 3, no?
Rule 5?
What rule 5 say?
It's -2 except when for oxygen.
There you go. So what is oxygen? There you go. What is hydrogen? What's your rule for hydrogen?
+1, is it?
+1 in the compound. So therefore,
But doesn't it have to go to compounds and 0?
it equals to 0 by rule 6. Right?
Compound.
The whole compound, the sum of the oxidation numbers must equal to 0. So you have -2 with your oxygen, and you have +1 with your hydrogen, but you have 2 hydrogens. So therefore your -2 and 2 + 1s cancel out each other and gives you 0.
So why do you have 1
One there here, because the individuals have this charge. You get it? It's the same thing you did over here, you know. So, alright, so go and do that for water. Go ahead. Come.
What?
Come.
So which one is the,
Come.
which one is the,
You tell me.
the reducing, I know which one is the oxidation, but the
Well,
other one's
then,
match,
well,
no?
no.
So CO2, carbon monoxide
Oxygen and,
to methane, that's the NRO.
What?
Carbon monoxide to methane, is that the NRO? And hydrogen gas to water is the POR? Okay.
So remember, the oxidizing agent and the reducing agent only come from your reactant side. You're looking at the change in the oxidation number in order to go back and say that which one is your reactant, is your oxidizing agent or your reducing agent. There you go. What? You get it? You like.
That's the question, where it says in a neutral compound, what does that mean?
So you don't have a charge on it. That's what I got to.
Because it went from 0 to 1. Alright. One more.
I didn't know.